Hello everybody, thank you for joining today's webinar. My name is Trevor Brown. I'm Business Development Director at Juniper Systems, and we're joined by Ryan Pearson. He's our Utilities and Public Services Account Manager. The topic of today's webinar is inexpensive sub-meter GPS options for local governments. And really the solutions we're going to be looking at today can be applied to a number of GIS applications, including agriculture, forestry, natural resources, or any kind of GIS and mapping application. So here's the agenda for today. We're going to try to keep this short and sweet and be concise and show you some practical examples of how these solutions can be used in local government. We're going to give a brief introduction of Juniper Systems Company. We're then going to have a brief introduction of the Mesa Rugged 2 tablet, as well as the Geode sub-meter GPS receiver. We're then going to use the majority of our time to look at some practical examples and use cases within local government. And these are more of some workflow examples that we know of that our customers are typically using. All right. So along the way, if you have any questions, be sure to just write those in your chat box, and we will follow up with those individually and respond to those. So feel free to use that. Write as many questions as you like, and we're happy to respond to those. So Juniper Systems, we are a U.S.-based manufacturer based in Logan, Utah. We design and manufacture ultra-rugged field data collection equipment. We manufacture both data collection devices as well as GPS, high-precision GPS. And we do have a parent company that's located nearby, Campbell Scientific. They specialize in manufacturing and designing data loggers used in things like weather stations and those types of fixed installed applications. And we do, as I mentioned, manufacture everything here at our site in the USA. We serve a diverse group of markets with reliability being a common need. And we really try to maintain the lowest warranty failure rate in the industry. All right, we're a relatively small company, but we have a broad reach. We do have partners and service centers throughout the world. We do have, again, as I mentioned, our main design center in Logan, Utah. We do have an office in the United Kingdom, and we also have an office in Kansas City supporting primarily our agricultural customers, as well as the same in Austria. All right, here's the hardware that we're going to have a look at and the solution. So we're going to be looking at the Mesa 2 rugged tablet. This is really an awesome field data collector. It runs both Windows 10, and you have the option to get it to support Android as well. So it has a speedy processor with a lot of memory, with upgraded memory options available. It has a long battery life, like all of our products, so it does last at least a full workday. And we do have options to extend that battery time, as well as what a lot of customers do is they just buy a spare battery, and they can do a quick swap of those batteries, similarly to replacing like batteries in a flashlight, for example. And then like all of our products, they do operate in extreme temperatures. One of the best features about the Mesa 2 is its high visibility display. It is a 7-inch display. We do use chemically strengthened glass. It allows for it to be impact and scratch resistant. We don't even recommend screen protectors for use with the Mesa 2. So like all of our products, it's built Juniper rugged. It is dust-proof and waterproof. It has an IP68 rating. It's the only Windows IP68 tablet that we're aware of, and it's designed to the mill standard 810G for ruggedness, so it supports drops, and it does support multiple 4-foot drops of concrete, and it does come with a standard 2-year warranty. So it does have a lot of communication options as well: long-range Bluetooth, Wi-Fi, and USB connectivity. It does have a high-performance GNSS receiver that supports both GPS and GLONASS satellites. And it does have a nice camera, and then options for barcode scanner and RFID as well. All right, the Geode sub-meter GPS receiver. Here's kind of a summary look at some of the key specs related to the Geode. Like I mentioned, it is a real-time sub-meter GPS. You don't require any kind of cellular network connection or anything like that, or subscription to get and achieve sub-meter accuracy. And that's all happens in real time using satellite-based augmentation systems. It is affordable. It really is the least expensive sub-meter GPS receiver that we're aware of on the market. And it's an all-in-one receiver. So it contains both the antenna and the receiver all in one device. You know, and the device itself is quite small and compact. And it does have an all-day battery life, as well as allows for connection to both Windows and Android. And like all of our products, built Juniper rugged. There's a number of ways to carry the Geode. You can carry it in a survey pole, has a magnetic mount option. There is a collapsible camera pole. This is one of my favorites. It's an inexpensive, basically, camera monopod that you can use standing, like the guy you see on the right. But I also like to put it into a backpack, and that way you can be using it for hands-free type data collection. This one also is quite popular. We do have a smartphone tray. So if you have an Android device that you want to use, you can just carry it in an inexpensive smartphone tray and enhance your accuracy while collecting data. And then here's a quick look at just the best thing about the Geode is really the accuracy. It works quite well. We wanted to show you some quick data on accuracy. And we also wanted to emphasize that the data we're demonstrating is not really a controlled environment survey type test. The data we wanted to demonstrate is more of a practical field data collection, similar to what we often see a lot of our customers using in municipalities and local governments. So you see here using that collapsible pole, the guy's just standing there at 4 surveyed points at our factory. And here you see some of the results. The circle you see is a 1 meter radius. So you see the points landing nicely inside of that 1 meter radius. The real-time accuracy from that test there, and again, this is used in just kind of a quick practical 60-second average test. You know, we like to quote our data, the NSSS DA 95% confidence level. And we see that at solid half a meter with a 95% confidence. So that circle there represents actually a 0.3 meter radius. This box here represents the physical size of the Geode receiver itself. We have the option to post-process your data to achieve better accuracy. And once we do that, we typically see about 10 centimeters. So again, the box there represents the physical size of the Geode receiver itself. All right, now we're going to jump into the kind of main content of this presentation. We're going to look at some typical workflows for local government. The first being what we call the traditional kind of GIS workflow. It's really kind of an alternative to some common use cases using Trimble products. It really includes, you know, a process workflow here where you have a phase to plan your project, collecting your field data, the optional step of post-processing, and then finally uploading that back to the GIS. So in our case, we're going to be looking at the EasyTag mobile software, which is one I like quite well. You can kind of view this as an alternative to Trimble TerraSync if you're familiar with that software. We feel that it has some enhanced features that make it more user-friendly and quite nice. The hardware we're going to be looking at is the Mesa 2 rugged tablet as well as the Geode sub-meter receiver. We're going to really just kind of compare it against, you know, all the various alternatives that are out there. And then we're going to look at the EasyServe post-processing software, which is really kind of an alternative to the Trimble Pathfinder Office. All right, so in that first step of the process, you know, we're looking at planning your project. You have the ability to, if you like, to create a custom data dictionary. So this is just really a nice step to kind of predefine what data will be collected out in the field and guide your users to make sure that they answer a series of questions when they're mapping the features that you would like for them to map. So you certainly have that option, and it's quite robust. It works quite well within EasyTag. You then have the option to just use clip maps from the web, and use those as a background layer in imagery, or you can upload your own high-resolution maps if you have those. And finally, if you would like to add additional layers, you certainly can view those within EasyTag, and you can do that by copying shapefiles to the Mesa tool. All right, so once you're out in the field, then it's a matter of just collecting your data. And on the left there, you see some data collection on the Mesa 2 with kind of a generic data dictionary that we set up. On the right, you can just see the Mesa 2 and the Geode. And then when you come back to the office, you can take that data that you collected in the field and use EasyTag or EasyServe post-processing software. So the first thing I always tell people about EasyServe is there's a lot of icons and it's a little bit intimidating when you first look at it. And that's because it really has a lot of features and functionalities that support professional surveyors. But if you're using it more of in a GIS environment, there really is only 3 simple steps to post-process your data. First, you browse to the files that you want to post-process. You then just push that button there, and everything just starts post-processing and finding the closest base stations to wherever the data was collected. As a reminder, in real time, the Geode receiver is getting about 30 to 50 centimeters. Once post-processed, you can get about 10 centimeters. Finally, the last step is you just export to the data to the file format that you prefer so that you can upload that to your GIS. And it supports export to CSV, KMZ, shapefiles, and AutoCAD DXF files as well. All right, so if we look at the cost comparisons typical with this solution that we looked at, with a common competitor price that we're aware of, if you look at the data collector, the field software, and then buying the post-processing software, you may be looking at a total of about $9,200, $9,300. You may have additional subscription fees as well that are required for purchase. With this setup, we're looking at a Mesa 2, a Geode, EasyTag field software, and the EasyServe post-processing software for a total price of about $4,200, $4,300. And we would really kind of consider this our premium setup. There's additional ways to save additional money if you would like to achieve sub-meter accuracy and just using a little bit different approach or some different selections on hardware and software. So one of those options, this is one way you can save additional money, is the Mesa 2. You can buy for a couple $100 more an upgraded internal receiver and antenna that allows for you to post-process that data to also get sub-meter accuracy. So you don't need to connect to the external Geode. If what you're trying to do is to create a highly accurate map and you don't need that real-time data, one option is to purchase the Mesa 2 with the upgraded internal receiver, get the EasyTag field software and post-process that. And you can save money, and that costs about $3,500 total. Also, if you have multiple users and you have 3 or more users that you would like to post-process your data, you can buy an open license to EasyServe post-processing for $1,500. So you don't have to keep repurchasing the post-processing software. You can post-process as many receivers as you like. So after 3 or more, you may as well just get the open license and post-process as many as you like. And finally, the last tip, if you really don't need the post-process and you're happy with the real-time accuracy of the Geode, which many of our customers are, you can use an Android device, for example, and for example, our Cedar Tree tablet, rugged tablet, and save money on hardware. And you can use a Geode sub-meter receiver, as well as some software, such as some Android software, such as one we'll just demonstrate later, which may cost a couple $100, or you may find an app on the Google Play Store, and that way you can save a lot of money as well. All right, next I'm going to turn it over to Ryan. He's going to discuss an Esri collector-based workflow.
Thank you, Trevor. Thank you for joining us today to learn about these different workflow methodologies. It's my privilege to talk about the Esri collector workflow. For those unfamiliar, Esri collector is a powerful application that typically is used with the ArcGIS online service from Esri. All Esri software customers who are current with their software maintenance are entitled to an ArcGIS online account and access to the associated apps. The Esri Collector app is one of the many ArcGIS online apps that are available to Esri customers. This slide shows 5 keys to successfully completing a project using the Esri Collector application. I'll address each of these 5 keys in subsequent slides, but I wanted to introduce them here. To properly execute an Esri collector project, it is critical that proper planning occur, that the necessary resources are available to build the project, that the project is shared appropriately to the organization, that field work is properly supported, and that the project be supervised and monitored. On the next slide, planning and Esri collector project will be discussed. Trevor, you want to advance that slide, please? Properly planning an Esri collector project cannot be overemphasized. Perhaps this is the single most important key to successfully completing any field mapping project. By properly planning, we are talking about defining the project purpose, clearly defining what that project purpose is. An example of that would be the difference between a simple utility pole inventory, mapping utility pole locations versus actually doing assessments of conditions while you're doing the inventory. Two different purposes in that project. That purpose will define the methodology for the collector application project. Once the project purpose is defined, the project method becomes easier to develop. Based upon the project purpose and the project method, it is important to identify the required resources. These resources would include your personnel, the IT infrastructure that would be required, and the field technology tools like GPS equipment and field PCs that would be needed. As a project is being planned, it is always wise to measure progress and set milestones, especially when working with other departments or agencies. These milestones help local government organizations see that the project is being completed successfully. Once planning is complete, we'll move on to how to build the ArcGIS collector project. So let's go to the next slide. Using the Esri platform, lots of tools are available to quickly build a solid collector-based project. Combination of tools in ArcGIS Desktop and ArcGIS Online help build the project. You'd start building the collector project by designing a database schema. The schema could be one of your own design, one that you may have used already, or could be publicly available database schemas from industry or from Esri themselves. Database schema is just a model that will be used for collecting data and storing data in the geodatabase. Once a database schema is designed and a map is created for the project, you would use the tools in ArcGIS Desktop to publish map services and feature services to be used in the collector application. You can see that in the graphic there as far as designing the map that would be used in your collector project using the ArcGIS Online tools. This is a simple process using tools in ArcGIS and ArcGIS Online. Once the map has been defined, the schema has been created, the last step would be using the tools in ArcGIS Online to modify the collector app to meet your data collection needs. This would include custom form design and data collection tools. Once this project is built in using the tools in ArcGIS and ArcGIS Online, it would now be time to share and test the application. On the next slide, we'll discuss the process for sharing the project to the work group. Using the tools in the ArcGIS Online, it is a very simple process to share the project to the members of the work group participating in the project. Here we see an example of using the tools in ArcGIS Online to share the project with our damage assessment group, a defined group of users who are participating in a damage assessment project. Once a project is shared to the members of the work group, you may want to test the project through a pilot program or employ other testing methods to make certain the application, the personnel, and the field technology meet the expectations of the project. By testing the application, the field technology, and the workflow, The project manager can make certain that the project is simple, efficient, and complete. Once the project is shared, we'll talk about the actual data collection process on this next slide. Once the project is tested successfully, it is now time to put boots on the ground and begin to collect and update data. During the data collection process, it is important that the project manager supervise and coach the field personnel. Coaching the field personnel gives them confidence and allows the manager to monitor the progress of the project as well. Here you see an example of water inventory where they're taking a photograph of a hydrant and recording other information, including the geographic location of the different water features. If the project is properly planned, the proper resources are in place, and the field personnel are properly coached, then the Esri Collector data collection project will be very rapid and it will be accurate. On the next slide, we're going to talk about the important role that a supervisor plays in the project. Constant supervision of the project during the data collection and mapping phase is critical. Supervising the project will reveal opportunities to improve the workflow, will build the confidence of the field personnel, and ensure that the project is being completed as intended. Esri provides tools like we see here with the operations dashboard, a tool again available in ArcGIS Online, to monitor the progress of the Esri Collector projects. In this instance, we see a map of the project area as data are being collected, the map's being updated in real time. In addition, we're looking at metrics in graphs and charts showing how much work's being done in response to the work being assigned to the project. It's important to provide regular updates to members of the work group. Being able to demonstrate progress to all stakeholders builds trust and will energize the group. If the project is progressing well and solid results are being realized, then you need to share this information with others. It's okay to promote the success of the project. Doing so will encourage others to undertake similar projects. On this next slide, I want to describe the advantages of the Esri Collector application and also discuss a few items to consider when creating a project. One of the greatest assets, or one of the greatest reasons to use the Collector application, is that it's a great collaborative tool, allowing you to work with other groups within your organization or even with outside organizations. The Collector solution allows projects to be prepared and deployed rapidly. Some of the Collector applications that are being used by our customers are deployed in from a matter of a few hours to just a couple days. The Collector application allows the work to be reviewed in real time or near real time. As a supervisor, you would have access to data as it's being completed by field technicians. And the another advantage of the Esri Collector application is that it does provide great flexibility in the workflow and in the technology platforms used in the field. But the Esri Collector application does have some challenges. Some of these I have already addressed in previous slides. If you lack proper planning and execution, the project may fail. If the resources and support are not available within the organization, the project may fail. If there's not proper supervision, training, and guidance, then the Collector project may fail as well. One thing to consider is the field hardware and peripherals. Properly selected field technology and position accuracy could negatively affect the project. The project may be derailed by choosing the wrong field equipment, even when other aspects of the project are executed well. On this last slide of my part, I want to talk about the different considerations in field technology. You'll find that field equipment and technology is generally the most underestimated key to successfully completing an Esri Collector project. It is frustrating to field personnel when the field technology doesn't meet the expectations or sometimes even fails to work at all. Consider the field computer platform, whether peripherals are required like barcode scanners or a camera to complete the project. Consider the location accuracy requirements, network connectivity, and equipment durability that meets the demands of the environment. These are all critical to successfully completing a project. This information has been presented already by Trevor, but I just wish to reemphasize our new Mesa 2, Rugged Tab PC, and the Geode GNS receiver as fantastic options for consideration when building an S3 collector project. These devices offer the latest technology and communication options. They'll meet the most aggressive demands to complete nearly any field data collection project. With that, I'll turn the presentation back over to Trevor.
Thanks, Ryan. Now I'll start by cover the last workflow example. We call it the form workflow. Really, you can kind of think of this as replacing paper forms if you have those that exist in your workflow. So, in this case, you have a lot of paper forms out there in order to collect data, and often that's because it's meant to be kind of a practical way to collect data, and there's a lot of sometimes even complex information on that paper that needs to be recorded. So what we're going to do is kind of show you a quick example of how you can migrate from paper into collecting all of your, digitizing that and collecting all your data on a rugged tablet app. So we're going to focus on this side here. You have this kind of process where you kind of create your spreadsheet or database. That happens in both sides. In our side, you have a little bit of upfront work on the, to create your mobile application. Then you have still the process to go out and capture your data out on a field PC, and the key benefits there is really to kind of keep your data protected, standardize your data collection, and integrate with other kinds of data. So when you create that in a digital mobile application, there's really a lot of benefits that you can have once you get into the field. And finally, one of the biggest benefits is just synchronizing your data to a database. And with the forms we're going to be looking at, you can export to common file formats. So really, you have the ability to save time with data entry, reduce data collection errors, and once you have it done, you can then just be repeating that process. So here's an example of the dry weather screening field data sheet. Really, these are people that are going out and inspecting a lot of water, stormwater assets. So you see kind of a complex form, and sometimes those aren't supported well in some of the typical software. So we're familiar with some form building applications that work quite well to kind of duplicate these paper forms and put those as a mobile app. And these are all meant to be used by people who aren't programmers. So you can create your own app and kind of customize it to how you want it to look, to match your user's needs, without a lot of programming skills. And so that's really the intent of these products. One we're familiar with is Mobile Data Studio. It's one we're quite keen on. So here you see, this paper form on the left. Here you're going to see what it looks like, once it's been recreated into a mobile application. You kind of have some sections or screens, that reflect each of the parts of the data sheet. If you drill down on any one of those, there's the data that you're actually collecting in the field. All right. So here's how, when you're first creating these applications, it takes a little bit of learning, but once you do it, you can, there's some great examples, and it doesn't take too long to create your own apps. In this case, you basically have a process where you're able to go and add the different types of fields that match what you had on the paper form. And so you just go through, and it has all the kind of different drop-down lists, photo integration, GPS integration, number fields. There's a lot of different options that are available to meet most users' needs when they're recreating paper forms into an app. One of the biggest things with these is test that app. Testing the app is key, making sure that it works before you deploy it out in the field, obviously, but often overlooked. Once you're out in the field, your users, they have these nice forms. They're user-friendly, and they have things like pop-ups that that give you big old buttons to use instead of the small default keyboards that are present with mobile devices. And one of the benefits is you can integrate data collection from various devices. So if you're taking photos, you can integrate that directly to the form. GPS, barcodes, RFID, laser rangefinders, even things like signatures and notes. You can integrate that right to your data collection. Finally, when you get back to the office, there's a relatively straightforward process to get your data. You can synchronize with databases wirelessly, for example, and you can export your data to common file formats if you prefer to work with files and moving files around. And it supports all the basic things like Excel and Microsoft Access, and it even exports to Google Earth, and Esri shapefiles. You also have the ability to then integrate directly to databases. If you want to map your fields to a database, it has that capability as well. And then it's really amazing that you have all of these features and functionalities, and it really only costs a couple $100 for the license, and that gives you the desktop application generator as well as a mobile license. And then you have a fee for each additional mobile license, but as you can see, it's quite affordable. And the Mobile Data Studio is one that we've used on a number of projects, and it's quite good. We're also familiar with a couple of other of these form building software applications that may work a little better depending on what type of projects you have, and we're certainly happy to discuss those. But for this typical setup, using a Mesa and a Geode, getting high accuracy GPS mapping integrated right directly with your form, you can do that quite affordably, and and that's kind of again a premium setup at $300 approximately. And really, that kind of concludes today's webinar. We were hoping to just give you some practical examples of how you can collect inexpensively and affordably sub-meter GPS accuracy, and how that really can apply to kind of local governments and municipal type typical workflows. Here at Juniper Systems, we love field data collection. We love to discuss your projects and happy to provide recommendations. Please feel free to contact Ryan and myself. Please do, if you have questions, go ahead and write them now in the chat box there, and we'll be sure to follow up with all of those. We're happy to discuss your data collection projects. I'm going to leave the webinar with our contact information here. And again, feel free to send us a mail directly or call us up at the factory, and we're happy to discuss your projects or questions, and we will do follow-up. Thank you, everybody, and have a nice day.